All right, let's dive into something really cool coming out of Google research. It's called nested learning. And this isn't just another small step for AI. This is a whole new way of thinking, blending the secrets of the human brain with the math behind today's powerful transformers. Seriously, it's a potential game changer.
So, to really get why this is such a big deal, let's start with a wild thought. What if all of today's incredible AI, the ones that feel so smart, are actually suffering from a type of amnesia, a kind of digital memory loss that's weirdly similar to a real human brain condition?
The condition is called anterograde amnesia. And, it's the perfect way to describe the problem with AI right now. See, once a model is trained, its knowledge is basically frozen in time. It can see new things, sure, but it can't really learn from them. The new experiences just vanish. They never become a permanent part of what it knows.
And this is the fundamental difference between us and AI. We are learning all the time. We adapt, we absorb new stuff. But when an AI tries to learn something new after its initial training, it often suffers from what the experts call catastrophic forgetting. It's like its brain is a full piece of paper. To write down a new memory, it has to erase an old one. So the system can never truly grow.
So yeah, this isn't just some minor bug you can patch, it's a really deep flaw in the very architecture of AI today. It's the reason that, for all their power, they just can't learn from experience the way you and I do.
Okay, so if we want to fix this digital amnesia, where do we look for the answer?
Well, we look to the best learning machine ever created, right? We look to the human brain.
And a secret, it turns out, is all about timing. Our brain doesn't just learn everything at one speed. Different parts of the brain learn at different rates. This lets us do two things at once. We can react super fast to what's happening right now, while also slowly, carefully weaving that information into our long-term memory. It's kind of like having a team of sprinters and marathon runners working together inside your head.
This slide breaks it down perfectly. You've got this fast online process that grabs stuff as it happens, your short-term memory. But the real magic happens later, in that slower offline phase. That's when your brain replays events, sorts through them, and decides what's important enough to keep, turning these fleeting moments into permanent knowledge.
And it is this two-speed, multi-level process from our own brains that directly inspired nested learning. It's a whole new AI architecture that tries to copy the brain's clever approach, creating a system that can learn fast and remember for the long haul.
So instead of thinking of an AI as one single giant brain, imagine it's more like a team of specialized learners, all working together but at their own pace. That's the heart of nested learning. It's a hierarchy where different layers learn at different speeds, letting the whole system process information in a way that's much more sophisticated and a lot more human.
Now, this layered system is the secret sauce. You have the fast layers at the bottom. They're like the first responders, just grabbing all the new data as it flies in. Then you have the slower layers in the middle. They're the strategists, looking at how the fast layers are doing and figuring out how they can learn better. And then the slowest layers at the very top, they're the architects, guiding the entire system's evolution over the long term. It's this beautiful self-improving cycle.
This table really drives home how different this is. A normal transformer is rigid, it's static. It has one learning speed and a fixed set of rules. A nested learning model, on the other hand, is dynamic. It's adaptable. It has multiple learning speeds, a fluid memory, and, get this, an optimizer that actually learns and gets better over time. It's really the difference between a static machine and a living system.
And this is way more than just a cool theory. Nested learning unlocks a whole new set of capabilities for AI, and the implications for how we're going to build and use these things are just massive.
I mean, just think about it. An AI that can actually learn from its mistakes. An AI that can take in new info without wiping out the old stuff. An AI that can genuinely improve itself over time. We're talking about optimizers that don't just follow rules but learn how to learn better. We're talking about models that can truly evolve. This solves some of the biggest problems in AI today. And to prove this isn't just science fiction, the researchers at Google actually built a prototype. It's called HOPE, which stands for Higher Order Processing Engine. It's a real, working version of nested learning built to show off what this new architecture is capable of.
And the results? Well, they're pretty stunning. You can see right here on this chart, the HOPE model went up against other AIs on some really tough reasoning tasks, and it just blew them away. It's a clear winner. This proves that nested learning isn't just a clever idea. It really, really works.
So what's the big takeaway from all this? I think it's that we are right on the edge of a massive shift in how we think about artificial intelligence. We're moving away from these static, pre-trained systems and towards something much more dynamic, much more powerful, and honestly, much more like us.
This quote from the research paper just says it all, doesn't it? Nested learning enables models that do not just infer, they evolve. We're not just building better calculators here. We're creating systems that can actually grow and change on their own.
And this is where it's all heading. It's a future where the line between neuroscience and computer science just gets blurrier and blurrier, where the secrets of our own brains are what unlock the potential of the machines we create. It's a future where we might build AI that isn't just intelligent, but maybe even wise?
And that leaves us with a final question that is frankly both thrilling and a little terrifying. If we actually pull this off, if we build an AI that can learn, adapt, and evolve all by itself, what does it become? What does the world look like when our creations start creating themselves? The next chapter in the story of AI is about to be written, and it is going to be a wild ride.